Hello, this is Greg Deckler, and welcome to Microsoft Hates Greg. Okay, so I don't mean to steal Brian Julius's thunder on any of this, but he did a really interesting poll, I thought. And in the poll, he asked, in the course of a typical month, how big is the largest data set that you work with in Power BI? And I think I know where he's going with this poll. It's related to kind of the no calculate approach. He really kind of grabbed onto that after my enterprise DNA presentation. He actually attended my user group and presented his findings on it as well, where he tried to go a month without using calculate essentially, and instead of using your virtual table X aggregator approach. And so he's been saying and we kind of agreed that, like, okay, at some point, right, even though initially with smaller data sets, the X aggregator is essentially just as fast as calculate. At some point, that's going to break down. At some data set size, calculate's going to perform much faster than X aggregate, than the X aggregator approach. And we both kind of said, this is good. This at some point, right? And so I know he's been talking about, doing some more work around that with larger data sets and that sort of thing. So I think that was kind of probably where he was going with this poll. But of course, then I see this poll, and one, I think it's skewed. So a quarter deal with 10 million plus row sets. I think it's a little skewed. I have a feeling because people that probably follow Brian are probably a lot of Power BI wonks, do a lot of heavy Power BI usage, and do a lot with those data, in Power BI. I'm not sure if this captures, like, if this is an accurate picture of the entire Power BI user base, if you will, like your typical business user. I still will cling to my claim, or my opinion, that the vast majority of Power BI data sets, are small data sets, and they're like single table type stuff. And probably much less than 10,000, 100,000 rows, in my opinion. But this poll definitely shows differently, right? So I was motivated. I'm like, oh man, now I gotta know. Where is it? What order of magnitude does the X aggregator approach break down? And and I'm probably gonna. I really, really go into this stuff with the best of intentions. I don't mean to cause controversy. It's not my intention to cause controversy, but I got to know certain things, and so I actually, I can't just accept somebody's opinion, even if that comes from a position of authority. I can't just accept that. I got to know for myself. I have to try it and do stuff with it and experiment with it. So I know for myself, my own. That's just I'm broken that way. So I'm probably gonna cause some controversy with this video, as you probably kind of noticed in the title of it. But let's go. So that was kind of the impetus for this. So I said, okay, let's go and create a 10,000 row table, and a 100,000 row table, and a 1 million row table, and a 10 million row table, and even up the ante, a 100 million row table. Um, I didn't go to a billion because this got really kind of painful. So I was like, okay, well, so we're going to stop at 100 million. And so you can see here, this is just a really simple code, right? It's just I'm using list generate. I convert it to a table, right? So this is, to 10,000. And then this one is to 100,000. I'm going to show you this so you can see I'm not cheating, right? 100,000. This one's 100,000, right? So this one is 1 million. I want you guys to think I cheated, man. So there's a million, and then 10 million, right? There's 10 million. You can count the zeros. And then the coup de grace, the 100 million row table, right? Okay, so basically what we did was we just created the index and a value, right? So this was the list.generate that we converted to a table. We just added a value column that just generates a random number between 100 and 10,000 is what it says. All right, and they're all built the same way, right? So okay, so that's what we did. So we ended up with our data set. So I got a page for each one of these, and all I did, right? So for my 10,000 row table, I created a calculate. Where I do a calculate, and I want to sum, the value column where the value is less than 500. And then I created the equivalent, SumX, right? Filter the table where value is less than 500 and sum the value. Okay, and then I did that for each one of these. They're all the same. They're all the same. I just changed. They just changed the table reference in each of them. Yeah. So, obviously they come out to the same number, right? 100 in this case, 126K. And then I started running performance tests on it. So let's see what performance analyzer says about it. So let's start recording, refresh the visuals. Okay, that's that guy, a little bit less performance, right? A little bit less, but no, now more performant, a little less, a little less. And so it's kind of, I don't know if any of this stuff, Brian, I have to chime in here, but these are the kind of results I was seeing, right? Is they're kind of all over the board. I don't know if they're statistically significant or not. That's a job for Brian. So okay, so I wasn't really seeing much of a difference at this level. So I'm like, okay, let's go over here, clear this up, start recording, refresh the visuals. Oh, less, a little more, less, like half. So again, I'm like, okay. So I'm like digging into these, right? I'm like, okay. And like what was kind of okay in this case, like the DAX query took 12 milliseconds versus 6. And that's where that's where I would expect to see the most of the difference, right? Is going against the data set to get the data, because I don't, visual display is who knows, and then other I don't even know what's included in other because they don't tell you. So it's other stuff. So I was really trying to compare, like, okay, going and getting the data set, and I saw a lot of these kind of things, like there we go, they're the same. I don't know why that one was, took twice as long down there, but probably, maybe an anomaly or something. I don't know. Okay, so it's all right. So didn't see any real performance difference at 10,000. Nothing really at 100,000. Let's up the ante, right? We'll clear this, start recording, refresh the visuals. Okay, we're at 1 million. And then less, a little bit more, less, a little more, less, right? That's my visual. This is the SumX visual. Oh, I probably should have said, yeah, SumX 1 million, right? I'm not lying. I'm not cheating. The top visuals always calculate, the bottom visuals always SumX. Okay. And you can see the same thing here. Like that's my SumX, 100,000. And this is my SumX of my 10,000, right? And this is my calculate. Okay. I want to make sure you guys know I'm not being dishonest in any of this. Just you're viewing the results just as I'm viewing the results with you. I've done it once before, twice before, but that's, got to do that. All right, so all right, let's go to the 10 million. Stop this, clear it, start recording, refresh visuals, less, a little more, less, a little more, less, right? So okay, not seeing a difference at 10 million rows. Okay, well, surely at 100 million rows, we have got to hit the limit. Stop. Here. Start recording. Refresh. A little more. Less. A little more. 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 So maybe this one's working. Maybe we're starting to close in. But in some cases, right, it's faster. So again, with the controversial statements, I guess, I fully expected going into this that I was going to hit that 100 million rows I was going to hit the limit, and that, the calculate, because I've been told the entire time from people that are in positions of authority that should know, right, that, calculate's super way more performant than X aggregation. X aggregates, dog slow, right? Not that dogs are slow, but just, terribly slow. And if you want to have something that's performant, you got to use calculate. But not in all cases. Right? And I understand that this is a simple scenario, correct? I mean, maybe in scenarios where you can use calculate and you're replacing the filter context versus you have to basically essentially open it up to all and then filter back down, which is a situation you have to get into with some X. Maybe in those cases, and maybe I'll create some of those cases and see if I can get them into here, and make some more videos on it. But these blanket statements that calculate is far more performant than some X. I don't see it. I mean, empirically, I don't see that it is far more performant. Um, Even in cases where, there is better performance at UVC, it's not like it's twice as much, right? Or anything like that. And in some cases you have situations where it's, almost twice as less amount of time, the other way. So, you know, it's a lie. That's all I can say is that anybody that says that Calculate is far more performant than X aggregators is a lie. It's a complete and utter lie. It's a blanket statement. Um, Maybe there is some truth to it at some point, but you need to qualify that statement. If you're going to go around slinging around, that Calculate is far more performant than XYZ, then show me some empirical evidence to back it up because I don't see it. And maybe I will. Like I said, these are very simple scenarios. I haven't gone up to like a billion rows. But I would have thought that you get up to 100 million rows, you're going to be seeing some major differences between those two approaches, given everything I've been told, for as long as I've been doing Power BI. But I don't see it. So it's a lie. And that's all I have. Don't lie to people. Tell them the truth. Prove it for yourself. All right. Have a good one, everybody.